All right, time to solve another differential equation. This one's going to come from the 2011 exam. It's a little bit older, but it's one of the ones that I found that seems to follow the theme. And I think this one may be actually a little touch harder than the one that we did before because it's more of a word problem as opposed to simply a quick problem with an equation and a graph. We're going to have to do some interpretation on this one. So we're going to see how this goes. So here comes the 2011 question number 5. So here we go. So this is at the beginning of 2010. Keep in mind that this test was done in 2011, so it wasn't very old at this moment in time. Seems like a long time ago now, but a landfill had 1,400 tons of solid waste. And the function that models the amount of waste in that thing, oh, it says it's an increasing function, which makes sense that, people don't usually take stuff out of a landfill. Some of it does decompose, but they're adding more in than what could decompose. So the increasing function W models the amount of waste in that landfill. And planners estimate that this differential equation right here sort of models the rate of change of that waste for a period of 20 years. So notice this isn't saying that this is a model forever, but it's just a model for a certain period of time. And very similar to a previous problem, let's use the tangent line to approximate the amount of waste that would happen in the first 3 months. So keep in mind, they're calling time zero this time in 2010, and that they're saying that there is 1,400 tons of waste. So if we want to do our little equation of a tangent line that we generally go to, keep in mind that we know that this y is actually this w as a function of t. We know that the amount of waste we have at that moment was 1,400. We know our value of time. I probably should use a t, not an x there. T minus 0. And then I need m, but m was given right here. So I need to find dw dt, which is, but I'd like to evaluate it at t equals 0 and at w equals 1,400. So if that's the case, it's 1/25 of 1,400 minus 300. So it's 1/25 of 1,100, which turns out, of course, 1,100, 1/25 of 100 is 4, and this is 11 of those. So that answer is actually 44. So our rate of change is 44, so we could say that our function w as a function of t is 44t plus 1,400. And that is the model equation that we're looking at for that tangent line. But now they'd like us to estimate what happens in the first 3 months. And they were being kind of nice here. They didn't want to really make anybody accidentally plug in 3. They're saying, let's use a quarter of a month, quarter of a year, excuse me. So that was actually pretty nice because, of course, a quarter of 44 is 11. So we have 1,411 tons of waste at month number 3. And we've got our first portion. Now, in this next question is we're supposed to find d squared w dt squared, which of course means let's go ahead and take this first derivative that we have and go get that second derivative. So if we start with the fact that dw dt is 1/25 of w minus 300, or, honestly, if you wanted to, we could call this 1/25 w, and then, of course, this would be, let's see, every 4 would be 12. This is where we got it. So now if we want to find d squared w dt squared, we take the derivative of this, which of course the derivative of this would be 1/25 times the derivative of the w with respect to t, which would be dw dt. But in the problem, they told us that dw dt was 1/25 of w minus 300. That's kind of the tricky part of that problem, is to realize that you're actually having to do an implicit derivative because we're taking the derivative with respect to time. So a little bit of an ugly set of numbers that we have right here. We've got 1/625 of W take away 300. And now it's telling me that if we were going to look at whether this value at 1/4 was an underestimate or an overestimate, we have to go and look at one more thing. So one thing that we know is in the given information, it says W is increasing. And we also know that since it's increasing, W is always over 1400, which means d squared W dt squared is also positive. So dW dt is positive. D squared W dt squared is also positive. So that means we have an increasing concave up story. So if we have an increasing concave up story, for any picture that we try to make a linear estimate, anything that we move over here to find will always be sitting underneath the curve. Therefore, this is an underestimate. That's a little bit tricky, isn't it? So they're asking us to make sure that we understand that an increasing concave up function, that tangent line will always be coming underneath it and therefore underestimate what we've got. And predictably, they're going to go one more step and say, hey, if we have this story right here with this initial condition, can we go one step further and come up with a particular solution to the differential equation? So I'm going to go back to the way that I had that a moment ago. Right here, I need to do a little separation of variables. As such, we're going to do an integral on both sides. This side is pretty nice, 1/25 t plus some constant. They will absolutely give you a terrible score if you forget that constant of integration, as would any math teacher. That's why we put plus C with like an 800 font up on the board during your test. And this is one of those tricky ones. Remember, that's a special case. So if you ever integrate something where you've got that variable in the bottom, that's a natural log. Now, technically, it should be an absolute value, but we did say that W was at 1400 and increasing, so that absolute value is not necessarily going to become an issue. So what we need to do now is we need to figure out what this C value is. So since we told you that 0 gives you 1400, if we plug in 1400 for W, that's the natural log of 1100. We plug in 1400 here, that's 1/25 of, that time was 0, plus C. So of course you can see that the natural log of 1100 would in fact be C. So if we were to plug that back in, the natural log of W minus 300 is 1/25 of T plus the ln of 1100. But of course, they, just like the previous question, they got to here, we're in pretty good shape, but they want W by itself or W of T by itself. And so we're going to have to get rid of this natural log, which means we're going to have to use one of those features back from pre-calculus where we know the base of this is base E. And if we brought that 300 across, we really would be technically done, but I'm going to go ahead and do one more little piece of this and know that when you take something like this, this is equivalent to saying e to the 1/25 t times e to the ln of 1100. I missed that. But that's actually kind of cool because e to the natural log of 1100 is just 1100. So there we go. It's 1100 e to the 1/25 t. And hey, we just have to move that sucker across. We've got this, our final answer. And just like that previous question, one of the hardest parts of the question was not actually the calculus. It was this boogery little part right down here at the bottom where just the algebra became kind of complicated. So I hope that actually made sense and that you could follow that logic. It's very similar to that previous problem. Of course, notice instead of doing a w to the -2, this one was w to the -1, which brought in logarithms, which I know a lot of you are not big fans of, but hey, it's been fun. I hope you guys are learning some stuff. Please be in touch if you're having any problems. All right, you have a great day.